Hello. Recently, I made a spellcast effect based on the 5th edition spell Agganazar's scorcher on Twitter, and I received a couple of requests asking me to make a tutorial or a video showing my work process and how I made the effect. Now, I have no experience with video making or editing, so I decided to start small. So I'm going to be making a tutorial focused purely on the beam part of that effect, which is what you're seeing on the screen right now. So to start, I will be using HDRP shader graph from Unity. It should work on any render pipeline and it should work on any shader editor. However, if you use something like Amplify, it might have different named nodes, or it might overall be a bit different, but the principles should remain the same. So to start, you are going to be needing a custom mesh. It is a very simple custom mesh. You can make it very quickly on Blender or Maya or anything like that. It's a cylinder without the top and the bottom, and it's been subdivided a couple of times because you need these divisions to make the distortion smooth. Otherwise, it's just like a really janky bunch of squiggly lines. So you can scale up your cylinder up to the size you want your beam to be, and scale down the sides of your cylinder to something a bit more like a minimum for um, your beam essentially. On the actual Agganazar scorcher effect, I used a very thin minimum beam because I wanted it to eventually fade out. So I used like this. Um, but if your effect is going to remain for a very long period of time on screen, you might want to use a thicker base. But let's just leave it at 0.05 for now. So here we have it. Now we can make with create shader unlit graph, a basic shader graph unlit. Let's call it beam inner. Let's create a material associated with it. And let's assign it to our cylinder. After doing that, we can just open up the beam and let's start with the shader. So in order to create the distortion effect, we're going to want to grab ourselves a gradient noise node, push its scale way down, and instead of just using it as is, we want to grab the object position and grab the object mode. What this does is it gives us the position value of each vertex based on the object center. And if we split that and we get the y, we now have a gradient noise that is purely mapped vertically. So you can see it's just a bunch of stripes. The reason we want to do this, and you can see that if I say put it into color, is because horizontally it all gets the same value, which is going to let us make everything grow evenly, like the effect on the left. So if we come back here, remove the color, lower the scale again, and now we want to feed that into the position. However, we can't just feed that into the position. First, this is just a value from 0 to 1. We need to add that to our object's original position. However, that's still not quite enough. And the reason why is, as I said, this is a value from 0 to 1. It's a single axis. This needs 3. So if I just do this, what's going to be happening is that every single vertex is going to receive a value from the gradient noise, so say 1 on the brightest parts of the noise, and it's going to increase all 3 axes by that same value, so that like a vertex might be moved like right 1, up 1, front 1, and that's definitely not what we want. So what we actually do want is we want to make it so the vertices move outwards in the direction they're facing. And the way to do that is to grab another node called vertex normal. No, not vertex normal. It's a normal vector, which is essentially the direction each vertex is facing. And we want to multiply the gradient noise by that, and then we add. This is now working correctly. However, it's going to be a very weak effect. So in order to stop that, we do want to add another multiply node. And this is just essentially an intensity modifier. We can connect anything we want here. We can just use a variable. So here, we can turn that into a property if we want to access it easier outside of the actual shader. So if we save now, you can see if I increase the strength, we can actually see the beam and its distortion. It's already starting to look more like the effect on the left. However, it's not moving, and when it's not moving, it just looks kind of like weird pottery. So we do need that to move. And the way we do that is the same way we do any moving texture. We want to connect its UV to a tiling and offset node. In this case, the UV is the y-axis over here, or the G channel in position split. So we do that. And then we connect the offset to a time node. You do usually want to just add any sort of multiply or divide node back here, just so you have at least some control over that. And now if I save that, you can see it's starting to look pretty good already. It's wobbling around. So next step is to add the color and to make it clampable so that we can limit it. So to add the color, you just add a color node, make it HDR, and say make a balloon for like a 2. Leave it as a 2 and a bit orangey. So there we go. It's now going to be colorful. And to make it clampable, what we want to do is you want to get this value. And before we allow it to be fed there, we want to make sure it's smaller than a certain value, a variable. So let's create that variable. So vector1 property. Let's call it let's call it clamp. Let's make it default of 1. Oh yeah, there's this bug. I gotta save the asset and close it again because Unity bugging out a bit. So yeah, slider default of 1. There we go. So we want to clamp the X and the Z axis to this. We do not want to clamp the Y axis because we just shrink our beam. So we do need to do is we need to split this so we got our 3 axes. We need to add a clamp node. Actually, we're gonna add 2 clamp nodes, I think. No, actually, yeah. We just need 1 clamp node fed here with a maximum equals to a clamp variable and a minimum equals to a negated clamp variable. That way it works radially. And then we split this and we only grab the axes we want, which are X and Z. We put those into a vector 3 and we grab the original Y and put it over here. And then we feed that into the position. Another thing we're going to want to do is we're going to want to multiply our clamp value by our strength multiplier. This is just so if we increase the strength, the clamp increases equally. Otherwise, you just get some weird effects. So here, this should be working. It's defaulted to 0, so as you can see, it kind of just vanished. But here you can see it's warbling, and I can make it go away. So this is how I make it on the Agganazar's effect. I make it vanish in the end of the effect. evaluate the clamp from a animation curve in a script, and then I go actually make it like go a bit lower, and then really fast lower. So now we have beam. It's already working pretty well, but we do want to add the little shadow effects. That's pretty simple to do, but we don't want to just copy and paste this all over again. That's kind of unnecessary. So what I usually do is you just select it all, because we're going to need this exact bit in a different um, shader. So what you can just do is you can just convert to prop. No, that was the wrong button. I actually want to convert that to subgraph. There we go. I just call it distortion subgraph, and there we go. All of that is one single node that if I right click, I can go back in and edit. I can then just feed the variables back into it, and it should work unless something broke on the sub shader, which it does seem to have. Let's just check really quickly here. Aha, here we go. This lost connection, probably because when I converted it to a property accidentally. So let's just fix that real quick. Now it should work. Yeah, it's working normally, and I can now create a different shader called, say, shadow beam. Create a material for it. Duplicate the cylinder, assign the new material to it. I can make it like a little tiny bit bigger, just like a little tiny bit, and open up the shader. And instead of just copying all of that and having like a big mess, and if I edit anything here, I'd have to edit on the other shader, I can just pop up our new beam distortion node, and there we go. It's gonna be working already. I just put the variables here. It's 2 vectors. Let's just call it 10, I think, and 1. And just quickly connect these two here. This is clamp. This is strength. We can quickly put a reference. Oh, we would be if you didn't have that annoying little bug. Value. There we go. So now it should already be distorting. As long as I make, yeah, the strength is actually wrong there, so let's just put that at 15.82. There we go. Now we just need to make it look like that. And that's pretty simple. We're going to need to make this transparent, and we're going to want to use black color, or at least almost black, and the alpha is what we're going to be controlling here, and we're going to be controlling it based on a Voronoi noise. I typically use variances of this noise for most of my fire effects, as long as they're like really cartoonish or stylized. And the reason for that is because if you feed that into a step node, and what the step node does is it grabs a value and it compares what you fed into it, and it says, well, if it's below this value, it's black, and if it's above this value, then it's white. And if you tinker with it, you can actually get this effect. And these like chopped up bits look like flames. And if you like do this animated, you can make them fade as if they were sparks. And if you, there's a lot of things you can do using this. You can, for instance, make it so the edge is smaller in the base and higher in the middle, and you actually get flame-like effects. It's a very useful node, especially when it's tied to something like Voronoi. And what we're just going to do, I just want to put that there. And just like we did in the distortion, we're gonna want to have time, and we are going to want to use it to tiling and offset the UV. And now it's gonna be tiling. It's a bit fast, so let's try with one, and let's save the asset. That's way too fast. So let's make it 1.3 maybe. Let's see if that's good. Yeah, that's a lot better. As you can see, it's a bit thin, and so what we can do is we can just, increase that a bit. There we go, looking a lot better. It's a bit redder than the other effect, but that's just a matter of tinkering with the variable and the colors. As you can see, the effect is there. And you can control these variables in the materials with script, and that allows you to use animation curves, which are like the best thing, to create impact and fade outs, and essentially do allows you to create what I made in the Agganazar scorcher effect. So I hope this tutorial explained well how to make the beam effect. If it hasn't, feel free to leave any questions you have in the comment section. I will answer them as soon as possible. You can also find me on Twitter. I do answer questions there as well. And uh, the if I find that this tutorial worked, I will see if I can make a fuller version with an entire effect and the thought process behind it. It's probably not going to be this exact effect, and since it's already been made, but I'll see what I'll see if I get any specific requests or anything of the like. Um, that's it, I guess. Goodbye.